So we have started from here. This ugly looking fraction was given, and we need to find its inverse Z transform. So we have, before applying partial fraction, we have to make it ready so that we can apply partial fraction on this fraction.
Yes, sir.
For that, we have to, first of all, we have to make all powers positive. Then we have to make the highest power of numerator one less than that of denominator.
Yes, sir.
Then we have to shift the extra Z on the other side. Then we have to factorize the denominator.
Yes, sir.
Then we have to introduce A and B. When we introduce A and B, we have to write A over first factor plus B over second factor.
Yes, sir.
Okay. Then we have to make equation 2 by dividing the denominator, by shifting the denominator on the right side with A and B. Then we have to apply, then you have to put values of Z by using the factors, because there are two factors, Z minus 1. So you have to take it, the first factor equals to 0 to get the first value
Yes,
of Z. Then you put first value of Z in the equation to get one of the numerator. For example, we are getting B in the first case, and then by using the second factor, which is Z minus 2, we have to take it equals to 0 to find the
Yes,
value of Z. Then you have to put this second value of Z in the previous equation. Then you will get A. After getting A and B, you have to put A and B in equation number 1, like this. You have to put equation A and B in equation number 1. Then you have to shift the extra Z again on the right side. You have to shift this extra Z on the right side, so it will get multiplied with the value of A and B. And then you have to do some manipulation. We have to rearrange the denominator so that it looks like the standard form, which is 1 over 1 minus A Z inverse. Okay. Then you have to figure out the ROC, because it looks like a two-sided signal, and it will be given. Definitely, obviously, it will be given in the question that whether the signal is right-sided, left-sided, or both-sided. Okay, one more thing. What if it is not given?
So then
we have to write all possibilities. Okay, then we have to write all possibilities: right-sided, left-sided, and both-sided.
Yes, sir.
Let me do it for you. If it is not given, you are required to find all possible signals. This was the final expression.
Yes, sir.
Now you have to write all possible signals. So this is the first possible signal. And we have assumed it as both-sided.
Yes, sir.
And for both sided, you have to mention the ROC as well. ROC will be z greater than 1 and z less than 2. Now let's write the second possibility. The second possibility will be the signal is right-sided. The signal is only right-sided. If the
Z
signal is
less
right-sided,
than
one of the
less
ROC
than
will be z greater than 2 and the other ROC will be z greater than 1. Now, what will be the final ROC? Z greater than 2 or z greater than 1?
so Z greater than 2.
Good. So z greater than 2 will be the final ROC, because if you consider z greater than 1, it will negate z greater than 2. It will oppose z greater than 2, because it is also going to include the area in between 1 and 2. Okay.
Yes,
So
sir.
if the signal is right sided, it means you have to make it, you have to write u of n with both. You have to write u of n with both. So it would be 8.5 2 power n u of n. This minus sign will be over here. Then 6. So it's up to you. If you want to skip 1 power n, you may skip. If you want to write, you may write. It's totally up to you. Now the last possibility, if the signal is left-sided. The signal is left-sided. You have to do this if it is not mentioned that whether the ROC is not mentioned, or if it is not given that which type of signal is this, left-sided, right-sided, or both-sided. Okay. Now, if the signal is left-sided, you will get these two ROCs. Now you have to finalize one ROC. Z less than 1 or Z less than 2?
C less than 2, sir.
No. If you consider Z less,
No. Less
then
than 1, because it will also
it also
include one.
includes the area, the region in between 1 and 2. It is not going to satisfy
Yes, sir.
Z less than 1.
Yes, sir.
So it means the final ROC will be Z less than 1.
Yes, sir.
Because Z less than 1 satisfies both, but Z less than 2 does not satisfy the first condition.
Yes, sir.
Now this is the final ROC. And now, as the signal is left-sided, so you have to write minus and minus 1 with both the parts. Okay. So it would become minus over here 8.5 2 power n u of minus and minus 1, then plus
Yes.
6 1 to the n u of minus and minus 1. No, I don't think you have to write. Okay, I have found a mistake, Ali.
Yes, sir.
This would be positive. It would become positive.
Because it's been added, right?
Why? Because this is the left-sided signal, and this part, if you consider this part only,
Yes, sir.
this part, if you take inverse Z transform of this part, you will get minus 6 u of minus and minus 1.
Yes, sir.
So this minus and this minus will get multiplied and you will get
And then
positive.
plus.
Are you getting or not?
Yes, sir.
Similarly, you have to write negative. Okay, it is already positive. It is already positive. So this is the final. These are the final answers of all possibilities. If the signal is both sided, right sided, and left sided.
Yes, sir.
So we have done with all possibilities, both sided, right sided, and left sided.
Yes, sir.
So you have to mention the ROC as well, because ROC do contain marks. Okay. So this is it for today.